Hello, my name is Pritesh Rajaguru, and this is Physics 2212, Lab 2, Line of Charges. So the purpose of this lab is going to be the exact same as Lab 1, except the difference is that we don't treat the charge tapes as if they were individual point charges, but as individual charge rods. This time, instead of just using Coulomb's law, we're going to be using superpositioning as well as Newton's second law. So the setup for this lab is going to be to create two U-tapes. Mine were about 20 centimeters in length, 1.6 centimeters in width, and about 2.3 grams in mass. Place one tape on two equidistant objects of the same height, and then make sure that one tape is held a certain distance away from the tape that's on top of the two objects. Mine was about 0.0442 meters away. You'll see that tape B starts to rise, and eventually it'll be suspended in equilibrium due to the electric force countering gravity. So some assumptions we have to make for this lab is that we have to ignore air resistance, and we're going to assume that each U-tape has an equal amount of charge evenly distributed throughout the tape. But unlike Lab 1, we cannot treat each tape as if it was a point charge. We have to treat it as if it was a charge rod, and furthermore, as if it had multiple point charges with equal charge. So this is the first part of my glow script model where I define the mass of each individual tape as well as the charge of the tapes, the length of them, and as well as the distance from charge B that charge A was. I also stated the number of particles I used in the simulation as well as defining the function to find the electric field. This is the second part of my glow script code, and arguably the most important part because this defines the line of charge instead of the charge being just a point on the tapes. This is a result of my glow script model if we assume that each charged tape was a charged particle, a singular charged particle, rather than it being a rod of multiple charged particles. As you can see, the electric force is far weaker than the gravitational force. This would result in the tapes collapsing on themselves and falling down rather than being suspended in midair. So this is a result of my glow skip model if we determine the charged tapes to be charged rods instead of a singular charge point. So in this one, we use the charge rod formula given during class to find the charge of the tapes. As you can see, the electric force equals out the gravitational force roughly. So this would mean that the charged tapes would stay suspended in midair rather than falling down like the previous code. So let's talk about some discussion questions. So what if we modeled each of the tapes to be a single point charge? So as you saw in the previous model, the electric force would be far weaker than the gravitational force. Um, it was actually about 50% difference between the charge of the tapes as if they were charged points rather than being charged rods. Also, why do these estimates differ, and what value is likely closer to the real one? So they're different because we use different formulas for them. Because we assume that the tapes were charged points, we use just Coulomb's law, and that gave us the wrong charge for the tapes. But because we use the charge rod formula this time around, we got a closer answer to how it would be in real life. And based off that, the real value is what we got in this lab, which was 3.72 times 10 to the power of negative 8. Thank you for listening to this discussion on Lab 2. I hope you guys enjoyed it.